Welcome to Programming Rainbow. In this video, we will be getting started with FFmpeg, how we can use it to capture audio. You can also use it for denoising, for EQing, compression, and declicking using a high-low filter. And we can do that in real time too. So if you want to follow along with the stuff that I'm going to be showing in this video, you can go to github.com, Programming Rainbow, and this one is just going to be called FFmpeg. And what's in here is just some scripts. So I'm going to cover on how to do everything, but these are just some example scripts that what different things, like if you were capturing the mic. And I don't use bash, I use fish. So I wrote all these in fish, but then I made a bash version as well for people who use bash. So there's just subtle differences, but you can choose the file you want. But again, these are examples, so don't use them straight. Use them as a guide. You'll need to change things based on how you want to EQ, how you want to compress, different things like that. So they're example files. Some of them get quite long, like for just straight up streaming to YouTube and Twitch, capturing video, audio, mixing the audio, mixing it with the system audio as well from the mic, and then everything. There is a script in here for that. This script right here is actually very much what I'm using right now to record. So mine looks exactly like this, except I didn't actually put, the YouTube and Twitch key up here. But this is what I'm using right now to stream this. Exactly like this, basically. What I'm going to do is kind of walk through this, but I'm going to use my example files. The reason I want to use files and not just the command line is because FFmpeg is it's a very large program. It does lots of different things. It's a command line utility, but it has just options for pretty much anything and everything that to deal with photos, audio, video, all kinds of stuff. And it becomes too difficult just to throw it in one command. So I just use a script and start breaking out different parts of the command into variables and then build up. So let's just kind of show that real quick, what that would look like. So I want to get the input from my microphone. So right here is my microphone that I'm using. It's an external audio interface, the PreSonus. It's an old PreSonus one. So the way that we could, to see what our options would even be, the command for finding out would be this one, list short sources. So this will give me a list of basically audio that I would be able to grab for FFmpeg if I wanted to capture from one of these. We have ALSA output, and we have the PreSonus one. We have two here on the PreSonus one. We have an output PreSonus, and its monitor, and then we have an input. This input one right here is the microphone. That's the actual microphone. The other one up here, the one that's the output, this is actually going to be the system sound. This is like if you want to monitor the system sound. If you were playing a game that was making sound, or you're playing a YouTube video, something that was making sound, that monitor is going to be your system sound. And it does not use your volume or your mute or anything like that. So if you try to change your volume, it's not going to change the volume of the sound that you're capturing. That volume is just changing the speakers that you hear. So you would do it a different way. So anyway, we have two things here. This input one down here is going to be my microphone right now. And if it was the internal one, here's the internal up here, right here. This is my laptop microphone. So we could use this one too. I'm just going to copy this one, the input, since I already have the other one. So, and we could put this up here too. I'm just going to put this up here and comment it out. I'm calling it A0, as in like audio input 0, the first one, and then A1 for the next audio input. I'm just putting this up here for myself real quick. Okay, so what we need to do is Pipewire that I'm using. Sorry. Pipewire is the audio system that I'm using right now. And I'm using the Pulse Audio plugin for Pipewire. So FFmpeg is getting audio from Pulse, which is going through Pipewire. So all that I care about is it's Pulse audio right now. So that command, that's the pulse audio control, and that gets the list of sources for pulse audio. FFmpeg, if we use a minus, again, this, what all this is I'm just breaking it down to make it more easily to read. So there's a -F switch for the file. The input is going to be this guy right here, which right now I have 2 of them. There, we shouldn't have 2 of them. So I would just take this right here, and you're going to see how this starts to get very long. This is just here as the variable. And then my output is going to be stereo. And the encoder, the codec that I'm using is AAC. And the file that I want to call it is this up here, which is, we'll get into that. We'll just give it a name. We'll say like, we'll call it a, let's see here. I'll put it in the music directory, and I'll call it a test file and M4A. Okay, so do you see that this gets quite long? So the reason what I did is I just used a backslash to break up the line to the next line. So I can do this. It just makes it easier to read. This one's quite long here. And then I've put stuff in variables again to make it more easy to, because it's going to get quite complicated. This is just for capturing. So if I wanted to capture my microphone right now, this is what I would do. So let's just try that. I actually don't know if this will work since I'm actually streaming from FFmpeg right now. I think it will actually work, but let me try real quick. Okay, so let's give this a try. So it pastes in, like I said, these are just like line breaks. It's basically saying it's one line. It's just allowing me to continue to the next line. I believe this will just work. So, and we are asking it to get the actual mic that I'm using right now. So let's find out. Okay, so this is a test of the mic. You should be able to hear me right now talking, but hopefully it's being recorded right here. So to stop this from recording, I'm going to press Q. And there we go. So let's go over to, and there is the file that I just created. These files I already had set up. These are pre-recorded, but this file right here should be the one I just recorded. So let's open this in Audacity. And remember, it is a stereo, but my audio interface is actually, I have 4 inputs on my audio interface, and this microphone is plugged into the first audio input. So it thinks the first 2 audio inputs would be the stereo. So it's actually mono, not stereo. So let's, if we listen to this, it would just be on one side. So let me just split this to a mono. And we'll be able to take care of this stuff too. I just want to show you actually just recording. And there's no processing happening with this. So this is exactly the way it sounds right now out of the mic. And what you're hearing in the video right now when with me talking, there is a bunch of processing happening. There's de-essing happening. There's denoising. There is compression and EQ and all this stuff happening. But this recording we just did, there's nothing happening. That's just raw out of the microphone. Okay. So let's play it. For one, the volume's going to be a little bit low because I'm mixing the system sound at half volume. So it's going to be quiet. But also on top of that, since I didn't use compression, for what we just did, the audio is also going to be very small for that too. So I'm just going to play it and see what it sounds like. Okay, so this is a test of the mic. You should be able to hear me right now talking, but hopefully it's being recorded right here. So to stop this from recording, I'm going to press Q. Okay, that's not too bad actually. Because I have the mic very close to my mouth and I don't have the gain very high, there isn't a lot of noise happening. So if I select a bit of this, let's, I'll just loop it here. There is a little bit happening. You probably might not be able to hear it in the video right now, but it is there and we can see that something's happening there. There is noise. It's not too bad, but there is noise going on. So anyway, so that's us capturing, and you can now see the reason why I have used this file. So all this doing right now, if I just I'm just going to grab this and put this on the command line. Okay, so if I open up a terminal here and I just paste this in, that's all that does. This is just getting the date as the year, the month, the day, the hour, the minute, and the second. And the reason why I do this is because if I'm making an audio video or an audio recording over and over again, I don't want to overwrite the name that I put in, and I don't want to have to keep writing in. We put test file in, right? But what this is going to do is just put this as it. And as long as I don't record two files in the same second, I'm going to get a unique name each time I record. So that is why up here I'm naming the file this, and I could even concatenate it with something else, but just for simplicity. And this is actually how I do my video recordings too. I name them with the date, so if I cancel a recording and record again, I didn't need to change the name, or I don't overwrite something that I've already created in the past. So I was using this up here. I'm going to back this up to the way it originally looked. I think that's it. Yeah, there we go. So you can see what that command was doing. And we could just type that command all out here manually. That's fine, but we don't need to do all that. Both of these can't be set, so I'm gonna change to the internal one, and it sounds much worse. But we're gonna see this name now. It's gonna be in the music directory still, because this $sign right here. If you've written a bash script, this is the equivalent to it. Directory equals. So this is the equivalent in bash. So fish does a set and there's no equals, and bash does it like this. So that's setting a variable called directory. And when I use it down here, I can use it with a $sign, and that gives me whatever was in that variable. And this file variable right here is what we've put in here, which is the output of this command right here. And then it's actually has a .mp4 at the end. So it gives it this name that looks like this down here, and then goes .mp4a, or .m4a, sorry, for the audio. So I'm going to delete this. So if we do this, we're going to have a much different sound now. We're going to have this internal microphone sound, which is going to sound much, much worse. It's going to be much noisier. It's going to have all the room echo. It's just going to sound a lot worse. And it should be named with this naming scheme. So we're going to be looking for a file that is similar named to this. And I'm just going to run this file instead of doing it in the command line. So this file is called mycapture.fish. And it should be saving it in the music folder. And I've made this executable. So I've already chmoded it with like a chmod like this. I've already done something like this on the fish one, on all of them actually. So I can just run them directly. I don't need to say bash or fish instead. I can just do this. And I believe we're in the fish one. So I'm going to do the same thing again. I'm just going to, this is a test. So this is a test of the internal microphone while I'm talking through the external microphone as well. But you'll be able to hear the internal microphone of my laptop here. And now I'm going to press Q on this. Oops, I'm not selected on it. There we go. Okay, so this is going to sound much worse. Here it is. Here's the file name with the year, the day, the month, all the way down to the second. It's got that file name that the script uses. And we have a stereo signal here. And I should have left some space for the, I should have left a little beginning space, so we could hear the noise of the microphone. But we'll be able to hear it. I'll play it. And again, this is going to be quieter because I mix the mic in at full level, but I mix the system sound in when I'm streaming at half volume, so the system sound doesn't drown out me speaking. So that's just the way that I'm mixing this video right now. Oh, I have this loop in the beginning here. This is a test of the internal microphone while I'm talking through the external microphone as well, but you'll be able to hear the internal microphone of my laptop here. And now I'm going to press Q on this. Oops, I'm not selected on it. Okay, so that was not very, that doesn't sound very nice at all. We will be able to fix that a little bit, but we're never going to make that internal mic sound nice. Now, I'm not I'm not professional audio engineer or anything like that, but basic stuff is if you can get the microphone closer to the source, like if you can get it closer to your mouth, that's better. Even if you have a cheap microphone, the closer it is to your mouth, the better it is. And I definitely have a cheap microphone. Okay, so let's see what else we can do here. So that's a way to capture a microphone. And like I said, you can see why I'm scripting things now, because it's going to grow and grow and grow. So we heard that the microphone is quite noisy. Maybe we can deal with some of that. So I'm going to do one more recording real quick, and I'm going to leave some noise there and then see if we can clean up that noise a bit. I'm just going to deal with the noise itself, and we'll see that two different ways real quick. So I'm just going to do another recording, but I'm going to leave some space just for the noise. Okay, that's enough space for the noise, and we will see what it sounds like when I'm just talking. So the new one will look like this. So here is our noise. Okay. So what we can do, I mean, I'm sure everybody knows with Audacity, we could just go up to this effects, and we can go down to noise, remove, repair, noise reduction, and we could get a noise profile. Yeah. And this noise is quite loud actually on this internal mic. And later on, when you use the expander compressor, you'll actually need to push the noise down even further, because we're going to be raising up the volume. But I just want to show what it looks like here. So right here, if I just space for the noise, let me stop that again. So that first thing I did was that selected bit. I selected a bit that I wasn't talking in, and I went to the noise repair. I'll show this one more time. And I have to click this button up here. This gets a profile of this noise. Now I can actually select the whole thing. I never know how to get rid of these, so let's just do that, whatever. I'm going to select the whole file now, and I go into that exact same tool, the noise reduction. And this time I can actually denoise the audio. And this is the main one up here, this 20 right here. That's saying whatever that noise is that's happening, push it down by 20 decibels. And we should be able to see that. I don't know if 20 will do it. Might. The noise is pretty bad on this thing. So we can already see that a lot of the noise is gone. Let's just do a play here. Okay. It is much lower. I would be able to hear this, but I can't hear it through me monitoring the video right now. And the problem is the more you need to, like, the higher the noise floor is, and the more you need to denoise it, the worse the audio is going to sound. So the noise floor before this on the, do I have the other one still open? I don't have it open. This one. Sorry, it is this latest one, isn't it? Oh, I could have just, I don't know what I'm doing here. I could have just undid. I'm confusing myself because I'm going to do this in another way in a second here. So this noise floor right here, it's around 30. Sorry. We'll see what it sounds like when I'm just... It's a 30 or a little bit above 30, right? It's pretty noisy. So that means we're looking at sounds in the negative 30 decibels, negative 25 to negative 30, and we got to push them down by like 30 decibels. I'm going to use that denoiser tool again, but I'm going to push it down further. I'm going to push it down by 30. And you're going to get this kind of under the water sound. It does a brilliant job, but it is degrading the quality of the sound. So just understand that. Enough space for the noise, and we will see what it sounds like when I'm just talking. Okay. You kind of get the idea what denoising is. Now we can do this in FFmpeg, and it's going to have the same effect. So we don't need to actually record it and do it in Audacity. We can actually just do it in FFmpeg. So we still have this file that's here. I'm going to undo this. I'm not going to save it. We still have this. I'm going to run, I'm going to modify this file that we've already recorded. Okay. And I'm going to put a denoiser on it. So let's see what that looks like. I'm not going to do it here. I'm going to do it over here. The file that we were getting before was here, right? But I have another script that I was using. Let's go up here. And it's going to have a lot of stuff in it. So I'm just going to kind of maybe break it apart a bit. So what this script is going to do is it's going to take an input file. So I'm going to give the name of the script, and then I'm going to give the name of the file I want to do something to the script with. And in Bash, it would look like this. It would look like AO input equals, and it would be like $1. When you run the script, if I give an argument after the script name and another string after the script name, this number 1 will be it. I believe 0 for Bash actually is the name of the script. Although this doesn't work for Fish. You can't put a 0 in here. This is a list in Fish, and this is indexing the list, but the list in Fish is 1 based. So 1 is the first argument. There is no 0. But anyway, so again, I have a Bash version of the same script, and I'm going to probably just delete a bunch of stuff from here. So we've seen the same thing up here. I'm setting the file name. I'm setting the directory name just to be easy for myself. Here I have the input file. Before, it was coming from Pulse Audio. It was the name of the Pulse Audio microphone or the internal audio microphone. This time it's going to be a file that I'm going to give after the name of this script. So I'm going to do that, and let's just delete everything else. I'm just going to delete everything else because we don't need to see all this yet. Let's see here. Yeah. Okay. So now it's going to look slightly different here. The input, we don't need this. We don't need this. Okay. Let's go to the other. Let's go to the other one. So here we had this. It's coming from Pulse, not a file. And I forget what the F, now I forget what the F stands for. I want to say it's a file descriptor or something like that. Now I forget what the F stands for. But the input is actually this file. So this is the input stream, and this is the file type, I believe. Okay, but since we're actually using a physical file that's already been recorded for what we're doing next, we don't need to put that. So there is no F here. This is just the input stream is the actual file that I'm going to be passing in, okay? So this is just FFmpeg -i, the name of the file that exists, which is going to be this this right here, this 2024, that's going to be the name of the file. Okay? And this is just saying it's the audio is 2 channels. This is the audio codec that we're encoding it to. And this is going to be the name of the file that goes back to. And we've already seen this name of the file being generated here. Okay. What this is doing is it's going to take our audio and put it to stereo. Now, the internal microphone was already stereo, but it's going to take the left channel and make the left channel both the left and the right channel. So basically, it's going to take a mono and put that mono on both channels, left and right. My external microphone, you saw that it was only on one channel. It wasn't on both channels. So one channel, so you would only hear it coming through one side. So this is going to put that on both channels. So that's all that's doing. And this is using pan. So let's go up and look at this real quick. So if we go to ffmpeg.org and then /ffmpeg -filters.html, we're going to get a list at the very top here. This is a very big page. Okay. So we have a list of all these kind of filters, right? And one of them is the pan filter. So I'm just searching this page for pan. There it is. I put a space in front of it to find it easier. So this just, it has an explanation for what's going on here. And there's all different names for like front left, front right. But you can just go channel 0, channel 1 as well, which I'm just dealing with 2 channels for stereo. So that's what I use. I use channel 0, channel 1. And I'm just kind of mapping channel 0 to both the input channel 0 to the output channel 0 and channel 1. So there is an explanation here, but sometimes it can be confusing. So let's just look at what I'm doing here. I'm saying pan, I want stereo. Okay, so pan equals stereo. Where is it? It is one of the options. It's just hidden somewhere here. So here's stereo. And basically you can take, say, C0 and you can put it to front left. You can put C1 equals front right. But I'm going C0 equals C0 and C0 equals C1. So I'm just taking the left channel and making it on the left and the right. I'm saying take that left channel, now you're left and right. So it's giving me a fake stereo. It's playing, it's still mono, but it's being played through both sides. Okay, so that's what I'm doing for here. Yeah, this args right here, like I said, that's just a way to pass in a name. So we know that this is the name of the file right here. I'm just going to copy that real quick. And this script should look just like the other one. So all this is going to do is take a, let's see, the file was stereo already, but they weren't exactly the same. See right here, this is this audio wave on the top here is not the same as the audio wave on the bottom. So this internal mic is already stereo, but what we're going to do is we're going to take this channel and put it on both. So they're going to both look exactly the same. So I'm just going to use this file name. I'm going to save it first. So this is file -mix. So this is like if you're mixing a file that already exists, you've already captured a file and you want to process it, you would use something like this. So I have the example on the GitHub. So this is also executable. So file, mix, and we'll use the fish one that I'm playing with. And now we need to give it another name. We need to give it where it's going or what the file is. Now this won't actually work right here because the file that we want to manipulate, or we're not going to manipulate, we're just using it as the input stream. The output stream is going to be a new file. It's not in this folder that I'm currently in. It's in music folder. So I'm going to use the ~music. And that's where the file is. And because I'm in fish right now, it actually tells me when it underlines it that, hey, I just typed in the real name of a file. That's why I like to use fish. Fish is a little bit more advanced. So when I process this, it should get a new stereo based on the old file, but it's going to be just the left channel twice. And it's already done. So I should have a new file. We didn't change the old one, so I have a brand new file. Okay, this doesn't look correct to me. Let's see. Let me just make sure I use the right file mix. Was it this? It should have been the 1625. Oh, I must have done the wrong file name. I think the original. That's why I have these named files down here, because I'm confusing myself now. This 1625 should be what we were doing here. Because it didn't look like the WAV file that I was already looking at. This didn't look like what I expected to see. Let's see here. Okay, this looks more like it. So this looks like this one here. Not that one. Sorry. Let me just close these. I'm going to close this. I just have two open. Okay, I want the 16. What is it? 1625. Okay, so this is the original file here. This one, and we can see that right here, they definitely don't look the same. The one channel does not look like the other channel. And this is the new file that we processed from it. And that's not right. I know what I did. Okay. I've messed up. I missed a couple steps. I have this pan. I need to use the, let's see, where is it? The filter complex. I need to tell it to filter. Basically, I have this pan that I put into a variable, but I didn't actually use it. So I can go in here and I go minus filter complex. I think that's right. And then something like this. Let me double make sure that that filter complex is spelled correctly. Filter complex, yeah. Filter complex allows you to put a whole bunch of different filters in. So I can use one filter, but then I can just keep making a filter chain. So instead of just doing one filter, I'll be able to chain a whole bunch of filters together. The output of one will go to the input of the next one. So yeah. So I have this filter here that we looked up, the pan filter, but then I never actually used it. I just created a variable up here. So you can see I can use it here like this, or I can use the name of the variable with a $sign in front of it. So it'd be A0 stereo. Okay, so that should do the thing that I thought was happening last time. And we were still going to use the same file that we're targeting, the 1625 file name. Okay, and I've messed up something here. Unconnected output. Okay. Also, typos. Okay, we get to see me making lots of mistakes here. There we go. Now let's see if, so we have one of these here. This should be the original one. And now I'm going to open up the new one. Whatever the newest one is, 3810. That should be the latest one. Now we should see that these look, see right here, these two look different because this is the original. Right here, they look the same. And you can see it's this top one actually. So I don't even think it re-encoded it. It probably just used the original encodings. So anyway, that's a very long way of showing you how to turn a mono into a stereo, or to take a stereo and just use one of the channels of the stereo, or to remap things. So that's the pan. So this is the pan. This is basically I need to use this for my microphone because otherwise it'll only be on one channel. And we did get a recording from my microphone before, but we can see this, what's happening. We know what's happening. So the next thing that we can do is probably deal with this noise a bit, right? So this noise here that we could deal with there, we could also deal with an FFmpeg. Okay, so I'm just going to grab it from close this. So we have a high pass, low pass filter. These are pretty self-explanatory. Let's just grab and throw them in since we're already here. And so I'm still using this file mix. So I'm just going to put it below the stereo. Okay. And let's look at it on the page. So this is, I think it's just called high pass. These are actually two different filters, but I just put them together because everybody in audio kind of knows what's happening with the high pass, low pass. Basically, it's just cutting off. A high pass just tries to cut off the lower frequencies and lets all the high stuff pass. So imagine you have a lot of low rumbling sounds, maybe air conditioning units or cars driving by outside that are like in the 50 hertz range or 60 or 80, even up to 100 hertz, but maybe not 100, maybe like 80. And you want to roll those low frequencies off. You would use a high pass filter. So this high pass filter here says 80, and I'm just using the default. I'm just saying, hey, high pass, the frequency starts at 80. And then I have a low pass filter too. So this cuts off all the very high frequencies and it starts cutting them off at 15,000. That's where it starts cutting them off. It's a gradual, it's a roll off. So it's going to affect a little bit of maybe 15, 16, a little bit more, just a little bit. But when you get to like 17, 18, 20, it's going to be cutting them off pretty well. So this is just two filters. They're comma separated. All these filters in the filter chain are actually comma separated. So if I were to put this pan filter and this, if I were to put all of these together in one line, it would look like this. I would just add a comma and then paste those in. And if they were in, if they were in the directly into the command, it would look like this. So I'm just pulling them out into variables to make it easier for me to deal with. Okay. So I'm just going to undo some of that, not undo that, undo that. So this is high pass. I want to kind of roll off frequencies that are below 80 hertz. And I also want to roll off frequencies above, because I don't need any of those. And they could be doing stuff that I don't want in my audio. So this is high pass, low pass. I just called them pass here. And this needs to be set and not equals, because I think I grabbed it from the bash, not the fish script. So I'm also going to grab another thing where I'm mixing these together. I'm basically building up a string of these. So what I did is I'm just referencing my, not that one. Where is it? Right here. So I could just put these together. Like I said, I could just, yeah, that's what I'll do right now, actually. I'll put this other bit in, but we'll just kind of put a pin in that for later. I'm not going to use these right yet. You can kind of see how I'm building these up though. Stereo, pass, denoise, click, to make it easy. But we could just put it right here. We could just put a comma there and do the, and I'm putting the, you don't have to put these quotations around the variable name, but it is more, if there's any kind of weirdness in the characters that you're using, the parentheses kind of helps deal with that. So it's a little bit more compatible, but they're not required. So we have the pass. That's the high pass, low pass filter. Okay, so we can just add them in like this. I just put this here. I'm going to use it later. I'm not using it right now. Okay, and this is just going to, well, let's see if we have. I'm going to look at this right here. I think this is the original one. I'm going to just, analyze it. I'm going to look at the spectrum. Okay, and we have, I don't know if this is going to show it very well. We have audio all the way up down to like 49 hertz and all the way up here to about 16. So let's try this with the high pass, low pass. And we can make it aggressive. You know what? I'm going to make it quite aggressive here. So we'll be able to see it. I'm going to put it at like 300. So it's going to really take off some of the low end. And yeah, we'll make it sound like an old phone or something. I'll put the high pass at 5,000 or the low pass at 5,000. This is being extremely aggressive just so we can see the effect of this. Okay, and I'm going to use the same audio again. So I'm using the exact same audio that we were using before. Unable to choose. I wonder if I need it to. Sorry, hold on. Let me try that way. I'm trying to build it up piece by piece. So I might be making little mistakes here and there. Okay, so let's open up the latest one again. And it looks very funny. It almost looks like, well, the denoising's there. So I want to look at this, and we should see the spectrum is really affected by this high pass, low pass filter. See this? There's sound, it has gone down, is decreasing. It always kind of looks like this. It always has this upward shape. It could be different. There could be bulges here and down, you know, pivot parts that are cut out a little bit, but it generally has this kind of shape as it's getting lower in the frequency, it's getting higher for the plotting of the spectrum. But you can see it's here, and you can see the higher bits. Let's see if I can do the one here. Okay, see how we have a lot going on here in the high end, and the low end is going up, and now the low end is going down, and this is much lower. So we can see that something has happened here. Let's listen to it. I'm going to close this one too. So wait. This is the that's not the one. This is the one we want to listen to. Okay, that's enough space for the noise, and we will see what it sounds like when I'm just talking. It doesn't sound too much different because honestly, the internal mic never really had much bass in it to begin with, but we could see it in this what's happening here. So let's carry on from there. So that's high pass, low pass. I'm not going to leave it on those extreme settings that I put it on. I think it was at 80 and 15. And you could change these settings to however best fits your voice or whatever sounds the best for you. So that's kind of why I want to explain this stuff. You may not want to use this pan, or you may want it set on the left or the right. So at least now you know this C0 is the first channel. Channel 0 is the first one. This C1 is channel 1. So I'm saying C0 equals C0, but C1 also equals C0. And this one here, the high pass, all the stuff that you want to go through is on the high end. The stuff that you don't want is not on the high end. So it's saying everything above 80, go ahead and go through. But the stuff below 80, we're going to start rolling it off. And the low pass is the opposite of that. Everything on the low end goes past, but stuff on the high end, on the low pass filter, stuff on the high above this number starts to get rolled off. Okay, so there's a high pass, low pass. There's our stereo. Let's go to denoising. So this one is a little bit more complicated. So let's just grab it in and we'll talk about it. And this one is also, you have to set this up for your microphone, and you kind of have to look at where the noise floor is and how much you want to get rid of it. So I'm just going to bring it into my file here. I'm going to close this other one. We don't need that. And this is all about the starting and stopping, like taking a sample. But this is the actual filter we're using, this FFmpeg. So let's look it up here. Right here. This is a denoise audio sample with FFT. Okay. And basically we need, like we did in Audacity, how we got a sample of the noise and we got a noise profile. We need to do that same thing in FFmpeg. So we need to tell it where to get the noise from. And what I do is I just tell it to get the noise from the beginning of the recording. So I just say, hey, look at the first second of the recording, and that's your noise profile. So you'll hear noise kind of for the first second, and then you hear the noise go away, because for the first second, it's actually not denoising. It's getting a noise sample, and then it starts denoising. Let's see if they have the examples. This looks very complicated. So here we have noise reduction. This is whatever the noise is, how much we want to reduce it in decibels. Okay. And then we have the noise floor. Okay. So the noise floor is like, where is the noise at? You want it to be as low as possible. So for my external microphone, my noise floor is at like 55 decibels. That means the sound I'm trying to get rid of is buried all the way down in 55 decibels. I don't want to tell it that the noise floor is at 25, because it'll mess with my vocals too much. But the lower you can have that noise floor, that noise that's being annoying to you, the further down it is, the better. But if your noise is at 30, let's see here on this recording. So right here. So this noise is like at 30 or even above 30. It's right here, okay? So if I told it the noise floor was down here at 55, it's going to get a profile of that noise at 55, and it's going to reduce that noise at But all the noise that was up here, all the other noise, it's not going to get rid of it. So for this to denoise this, I need to tell it the noise floor is at like 30 or 25. And that's going to greatly affect my audio. It's going to make my audio sound like it's underwater, and it's going to sound funny. But for the mic I'm talking into right now, my noise is around here. It's like at 50, it's below 55. So when I denoise that noise way down there is not affecting my vocal very much. It is kind of annoying to hear it, but it's not really affecting my vocals too much. So that when I push that down, it's not as bad. So the worse the microphone is, the noisier it is, the more you have to raise that noise floor to get that noise, and the further you got to push it down, and that more it's going to degrade your actual vocal. So yeah, for this, it's quite bad. It's like 25 to 30 decibels is where the noise floor is at. And when I say that, 0 is like the maximum sound we can have is 0, and everything quieter than that is less than 0. So everything's a negative number all the way up to 0. So the noise being at 30 decibels that you saw it jumping around here, that's very noisy. Okay, so that's an explanation, but FFmpeg needs to get this, like we trained here with the when we went into here, noise reduction. When I click this button, get noise profile, that's whatever I've selected here. It's going to look at that and says, that's noise. Okay, I know what noise looks like now. And then when I come back in again after I've selected the whole file and I start pushing that noise down by pressing OK on this, that is going to now affect the whole file. So in FFmpeg, what I do is I tell it to record at the beginning. I just say, hey, listen to the first second of sound. That is what your noise looks like. Okay, so let's go back to here. This is quite, yeah, right here they have a little bit of it. So it's saying the start right here. And wait, where is it? Oh, I think they just have it starting at the start, and then it's going for a fourth of a second, and it stops. And then what it's saying here is the noise floor is -40, and push that noise down by 20 decibels. Okay, so what I have here is again, this is all just would be in line like this, you know. Okay, so I'm using these first two commands to say when I want to start, and I'm saying between 0 and 1 second. So I could put a half here. I could put 0.5 and it would be half a second. And that's my noise profile. And then here is what I'm doing with that. And I'm saying my noise should be at -55 and I'm pushing it down 20. So I don't think it's going to work this way for this one. I'm going to undo this. What I've changed here. Okay. I think our noise is much higher. I think it's at 30 or 25. And I think I need to push it down by 30. And this is very extreme. Like I said, that internal mic sounds terrible and it'll never sound good. We'll make it sound a little better, but we're going to get some kind of weird artifacting where it sounds like you're underwater with this extremeness. But there's nothing that you can do to make that microphone sound good realistically. You can just make it sound better, but you can't make it sound good. Okay, so I'm going to try this, and we need to use it. Again, I'm using the bash version, so we're in a fish script. And down here, I should just be able to add it in. So I'm going to set it to stereo. I'm going to do the high-low pass. And then inside of here, I am going to do the denoise. Oops. A0. Denoise. Yeah. Okay. So again, I could just grab that whole long line and put it here, but it would start getting longer and longer. Okay. And we're just going to process the same file again. We're not changing the original file in this. We're creating a new file each time. That's why I have to open up a new. But I'm using the same file as the target. So let's look at what our noise looks like here. Okay. It looks like there's still noise. So I'm thinking what I did is the noise floor is not 30. It's 25 or 27 or something like that. But it's probably way better sounding than it was. Let's go back and set it a slightly higher. Or let's find out how to actually find the noise floor. Okay. So what I'm going to do is I'm going to set this extreme. I'm going to set this to like -50. Yeah. Just because I'm hunting for where the noise floor is. So I'm going to leave 30 here and I set that to 50, but I think we're still going to get noise because I think it's my noise floor that's the problem. So the reason why I'm setting this so extreme here is because I want to dial this in to find the correct. We don't want this to be too high, but it needs to be high enough that it's getting the noise. So I'm making this very extreme just to look for this number. Okay, let's do that. And we'll go over here. We'll open up the new one again. If we still have noise, it means that it's it's not correct. But you might always just have noise, you know. I'm just showing you how to like really. Okay, so I believe it's not there. It needs to be up a couple decibels. So let's look at let's say 20. Let's try 27. Okay. Maybe it's 26 or 25. Oops, wrong one. Okay. Yeah, it looks like it's probably 25. So now that I've set it so it's extreme, let's say this is 25. But this doesn't need to be 50. Okay? We don't want to the more aggressive we are at pushing the noise down, the worse it's going to make everything sound. So it's a play off of trying not to make your audio sound bad, but also trying to get rid of the annoying noise in your audio. So let's try 20. So our noise floor is 25, which is incredibly high. We're pushing down 20. That's still quite aggressive, but I don't think it's going to be enough. But let's just see what it's like there. I'm just going to close this old one. Okay, I'm just going to listen to the audio here. Okay, that's enough space for the noise, and we will see what it sounds like when I'm just talking. It's not too bad, actually. The thing is it's not compressed yet. When we raise the volume of this. Okay, that's enough space for the noise. When we bring this up a bit, let's say let's normalize it or something. Okay, that's enough space for the noise, and we will see what it sounds like when I'm just talking. It's still not bad. It's not. I mean, like I said, for the internal mic, it's not too bad. We're just gonna move on. Okay, so that is how to kind of set up the denoiser. Like I said, the more that you denoise, the worse your audio sounds. Also, the higher the noise floor, the worse it down. So you kind of want the noise floor to be very low. But again, my laptop's internal mic is really bad, and also when I'm stressing it and it's doing anything, it gets even noisier. So this is really just showing you what noise looks like. I wouldn't use that microphone. This external mic, the noise floor is like -60, -55, and then I only need to push it down a little bit too. Like 12 or something. Okay, so yeah, so we have that. What else can we do here? We did the stereo, we did the pass, we got the denoise. There's a declicker, and I wasn't able to get these kind of working. I don't know if they work properly. I just chucked them in anyway to get rid of clicks and the de-esser, but I wasn't able to see an actual, what I noticed would be a change. So there is settings for these as well, but again, I didn't find any settings that actually did anything that I was able to notice at the time, but I threw them in anyway. So they look like this, and the one is the AD click and the de-esser. So if we go here, DE click, So this removes impulse noises from the input. And there's different settings here. I played around with this thinking I was going to get rid of some clicks. I don't think they were the type of clicks that this gets rid of. So, but I just left it in anyway. So like I said, there's probably more options you can put onto this. This is just the default. And the same with the de-esser. There's options in here. I'm not an expert and I didn't get it to do anything that I noticed. So this one, again, there's some options, and I did try different options and stuff, but when I was trying to get rid of an annoying, what I thought of an S sound, the de-esser wasn't doing it. So I think it was just the way the microphone was working, and it wasn't really, it wasn't seeing it as an S. So I just put those two in anyway. I figured they're not hurting anything, but I wasn't really noticing them doing anything. So the other thing we can do for these filters is, right now I'm just kind of putting the filters inline here, but the reason why I have it here is I can actually tell it what I want. Yeah, I can make a filter, kind of filter chain. That's what this is. This is a filter chain, right? But I can tell it what audio I want to be. If I was having multiple audio inputs, I could give it a name. Actually, we can just remove this till later. And we can remove this. Now we could just cover it later. So we could put the stereo, the pass, the denoise, the declick is all here, de-esser. And we'll go to the next one. And I'm just going to replace this with this filter up here, which is just basically this string. I'm just calling it filter. It's basically my list of filters. So this is just another variable. Again, this is a bash version. I need to do the fish version. Here's the fish version. So this is just another variable, so I don't have to write them all out here forever. So we already have all of these set up here. We have the stereo, we have the high pass, low pass, we have the denoiser, and then we have the click and the de-esser. So they're all in here. Stereo, pass, denoiser, click, de-esser. And now we get to equalizer, which is a little bit more interesting. Oops. So let's just make sure that this works first before we do the equalizer. This abstraction that we've done into this variable here. So I'm just going to run it on the same file again. And it looks like we've missed something. Wait, did I put an equals somewhere? Oh, right here. I'm using the other, I should have been using the fish version instead of the bash version of the other file that I keep copying from. Every time I bring something over, it's in the wrong format. Okay. And I'm going to assume that's done the same thing as before. So for the, let me just go to this other file here and close it. Okay, we are doing file mix. That's what we've been working on. And I'll grab it from this other fish version. Okay, yeah, that's where we're at. So here we go. Now, if we want to equalize, we can do an equalizer just like this. And again, I've written this down. This would all be one long line, and I've written it down. So this is the FIR equalizer. And let's look at it here. Equalizer with the arbitrary frequency response. Okay, so it just does what an equalizer does. So what we have here is we have a bunch of entries. So I'm going to just show you what this looks like in line. It's going to look like this. There's the actual for equalizers equals gain entry, because we're going to be playing with the gain of different frequencies, equals, and then it would be it could be a double quote or a single quote, but since I already have this in a double quote, I'm using the single quotations inside. And then we just have a whole bunch of these, and each one of these are separated by a semicolon. So they could be in line like this. You know, it would be like this. That's how it would look in a line. So you can use a double colon if you're just writing out one line, but since I'm separating that out into variables and I've already got a double quotation here, I'm using a single quotation here. So it looks prettier for me. I'm just putting the thing here and all the entries down in a line. So this is saying at 100 hertz, bring the gain down 1 decibel. At 156 hertz, bring it down 2 decibels. At 220, 1 decibel. And you could put them positive too, but I generally EQ negatively. Again, I'm not a professional, so maybe, you know, sometimes I've used positive, but I generally cut. But this actually just lines up with, if we were to use the effect here, where is it? I go down to this multi-band EQ. This one here. So I was just playing with this EQ here, and what I thought sounded nice, you know, in Audacity, I would just listen to a recording I had, and I just typed in these numbers. Now you can just put in whatever frequencies you want. I believe they need to be in order. They can't be out of order, but you know, the 100 hertz, 156, 220, that just lines up with 100, 150, 220. What I was doing here, I was like, yeah, that sounds good here. I'm going to port that over. So you can put any numbers you want in, and you can put a whole bunch in. It doesn't really matter. So you can, you know, if I wanted one in between here, I could put another one in, and I could do entry. And I could do it like 350. And it would look like this. And I could say, I want it to be plus 5 there. And I would need another semicolon. And this backslash, this is just because I'm breaking it up into multiple lines. Okay, so you're going to want to EQ however you think it sounds good. One of the things I tried out with a little bit of success is by taking, this is kind of the blind method. You don't know anything. You're just trying to make your audio kind of flat sounding. You just want to make your audio flat sounding and then EQ it afterwards. If you have no clue where to start. What I did is I just dropped everything. Just dropped every single channel all the way down. Sorry, I'm using a touchpad here. Usually I try not to use the mouse too much, or touchpad. So when I have everything dropped down, you know, if I play this audio part, I'm getting nothing out of it, right? But if I go up here to, if I go to here to 100 hertz and I hit 0 on it, I got some sound coming through, right? And it's peaking at -22 to -21. Okay. So if I put that back and I do it here, see, this one's going up to 16. This one looks like it's around 22 again. So I kind of look at a couple of them and I say, right. Okay, so what I would do is I'd actually open up 2 of these, and I would basically target a number. So if I press stop, it's going to reset this guy right here. And if I play it again, it's going to show me whatever my top peak was. And let's say I target like -22. Yeah. So this one is going to be fine. It's negative 22. And the first one was also negative 22, but this one wasn't. This 156 was much higher. It went all the way up to 16. So I could drop this down by, say, 8. Do I need to slide? That's weird. Okay. I shouldn't need to do that, but it wasn't responding. Okay. Let's see where it peaks at now. I actually have the volume not maxed out too. It's at 5. I don't know if it was originally there or if I was messing around. That's negative 7. Okay, so I'd probably go negative 7. So what I would do is I would go into the other one and I would keep track of it. I might have 2 of these exact same, but one of them turned off. I'm just talking. Sorry. I would turn one of them off and I would just keep the numbers in to store. And then I would transfer it over to FFmpeg and put those numbers in. Like, right, it was 0 for here was fine. Negative 7. The next one was 0. And then after that, what would the 310 be? 311, sorry. They're down. So it looks like a couple decibels need to come off this one as well. Wait, did it go all the way up to 13? And this is not really scientific. It's just kind of making sure the peaks, don't exceed. It looks like it's at 20. So I'd need to take it down by like 2 or something. Why is this not? I don't know why this is not selecting right now. This is acting very strange. Anyway, I'd take it down by like 2 or something like that. And I would go across all of them and I would set them and then I would look at the profile again. So I need to close this. I would look at the plot spectrum. And this is telling me there's nothing happening in the bass and there's way too much stuff up here. I would want kind of a line going like this. It should be this diagonal line because all of the frequencies are peaking at the same spot. So I have way too much stuff going on here. And I'm probably missing out a little bit here. Where are we at? We're at 400. Yeah, I probably need some stuff going on here. But the internal mic doesn't really pick up any bass. So I would probably boost the bass a little here, bring this down a little bit, bring up here a little bit, bring this down a little bit, and try to get a diagonal going through here. And then I'd be cutting really heavily here. And that's just to get a more neutral sound. It's not really scientific. It's just basically using all the peaks. But when I looked at the analyzer, it would give me a flat. Yeah, it's diagonal, but it would be like a flat response. You could do that. Like, again, I'm not a professional audio engineer, so that's just something I was doing because I had no way to generate pink noise that was, scientifically correct and all this. Or you can just play around with it until it sounds good to you. But that is how you do the equalizer right there. And this equalizer is not for that mic. This for the one I'm actually talking to right now. It's just cutting some of the mids in the 400 to 800 is all that's really happening. But we can just apply that and see it working. And we're not really going to hear it, but it's. Did we still have the same? Yeah. I was just making sure this wasn't still messed up. So that's how you would equalize. Okay. And that would be applied now to the new version. If we open it up again. Like I said, that equalizer is not for this mic, but it would have changed the shape of this slightly. Oh, we could do some stuff here. Let's do that. We'll equalize something very heavily here or something like that, and we'll see it. Sorry. What was the frequency range? So it looks like 5,000, just 5,000 up. So if we went pretty heavy here, if I went, say, negative 15, then negative 20, negative 20. We have the high pass, low pass, which is going to do some stuff here too as well. But we should see something in the graph. So here we should see some kind of difference going on. Oh, I don't see any difference. Oh, I know what's going on. We didn't add the equalizer to the list. So nothing happened on that one, actually. Let's go back. And see this equalizer? I removed it from the list. So to add it, we need to, these are all comma separated. So I need a comma, I need that line break, and then down here, we're going to add in the equalizer. And that should be good. Over here. Let's open this up. Okay. Yeah, see down here, big difference happened. There was some other stuff going on too in the EQ. Again, we're not going to really listen to it. Again, the EQ is not for this mic. Just know that the EQ is doing something. It's working. Okay. So we've EQ'd, but we want compression. And actually what we're going to use is something, a compressor and expander. So where is that here? It is. Wait. Should be. Oh, I've done the. I hate it when I clicked on the bottom file, and then when I click on the other tab, it opens it up in the bottom window. That's my fault. Okay, here we go. So this is going to be what the compressor looks like. All of these look slightly different, so it is a bit frustrating. Like the syntax of how they're separated. Sometimes they're separated with pipes. Sometimes they're separated in semicolons. Sometimes they're comma separated, you know. So this one is separated. Each thing is separated by pipes. So this is comp and. So let's look this up real quick. Okay, so this is a compressor and expander. So in a normal compressor, you raise the volume up, and then you apply compression to a certain gain. Like say your audio is peaking at 0, and it's causing crackling. It's way too loud, and you want to make it peak at like -6 or something like that. You would add compression, say when your volume got up to -10, you start adding a 2-to-1 compression or something like that, where it starts for each decibel going up, for each 2 decibel goes up, it only goes up 1 decibel. So at if you start applying it at 10, when you have input audio that is -8, it's actually going to be -9. And when it becomes -6, it'll be -8. It's going to go up 1 decibel when the input's gone up 2 decibels over the threshold, which is 10 in my theoretical explanation of this. So basically, it's taking the highs and applying compression to the highs. But a lot of times you add gain to the entire thing. So you might have audio that's not loud enough, and you want to make it louder, but you don't want the peaks. You know, you want more peaks, not one loud peak. So you bring the whole volume up, and then you apply compression to the top to get rid of those peaks. What this does is, instead of doing that, it takes stuff that's not loud enough and it expands it. It brings it up. But then when stuff is loud, it applies compression. So it's slightly different than what I think of as a compressor before. which means the noise, if you have noise in your audio, if you applied the traditional compressor with just applying gain first and then compression, you would have the noise because you're applying gain, so your noise would get louder. And then your compressor would just be taking off the tops, compressing down the tops again. So your noise would be there. You would have to push your noise down further. But with this compressor and expander, what happens is your noise will show up and disappear sometimes, depending on how loud your input volume is. So your noise, the noise doesn't stay the same. It's not the same. It's actually dynamic. If you're talking very loudly, the noise might not be too, if you had a little bit of noise that you didn't get rid of with the denoiser, it might just be a little bit in the background. But then if you start talking quietly, the expander raises the gain up on what you're saying. And now that noise that was quiet is louder noise. So with this, the noise is more annoying because the noise gets quieter and louder. So you do want to make sure the noise is out of your system. But what happens is you get to tell it what you want to do with each. And again, you can add in as many points as you want. But what I want to do is I'm targeting -6 decibels. And when I target -6, it actually goes up to like still -3 or 0. It doesn't actually stay at -6. This is kind of using a mathematical formula to do this under the hood. But this is my input over here on the left. The left is my input. When my input is -180 decibels, I want my output to be -180 decibels. When my input is -54 decibels, I want my output to be -90. So I'm basically saying, hey, when I have quiet stuff happening, maybe somebody walked through the room or something fell or a car drove by outside, which the roads in front of me is very loud. Those things are much quieter than me talking, but I would still be able to hear them. So just make that stuff quieter. So I'm actually pushing that stuff down. I'm saying, hey, stuff at this low volume, make it even quieter. But at -51, I just want it to be neutral. So basically, at -51, whatever that audio is that audio. But when it gets a little quieter, it gets pushed down deeper. When it gets louder than 51, it starts getting boosted. So when I'm at -48, which is 3 decibels higher than -51, I'm actually boosted to -35. I'm assuming I'm whispering now. I have my vocals are coming in now. And I want those to actually not be a whisper that people can barely hear. I want them to be more audible, right? So I'm really boosting it. But as I go up, I'm boosting it less and less and less. So what's happening is they converge at -6. And the furthest they're apart is at what I'm doing here is I'm saying, hey, at -6, I'm -6. At -12, I'm -8. So when I've gone down 6 decibels, I only want to go down 2 decibels. When I've gone down 6 again, I want to go down another 2. 6 again, another 2. 6. But there is a point where I'm actually talking quietly, and I want to start not boosting stuff anymore. There's going to be like a mouse that farts, and you're going to hear it. I don't want that. So when I've looked for where the part is where my voice is quieter and quieter. And then I say, okay, that's quiet enough. I'm going to start letting that get down to natural level. And then stuff below that, I'm just going to get rid of. So it's kind of, this is doing two things. It's getting rid of quiet noises, and it's boosting other quiet noises that are a little bit louder quiet noises that I actually want to hear. But as I'm getting up to next to -6, they're coming together. So I hope that makes sense. I don't know. It's not a very good explanation, but basically I do want, if I'm talking at like if my voice is coming out at -30, I want it to be 14 so you can hear it better. But if I'm louder, I want it to just be a little bit louder because I'm going to end up at 6 where they're the same. When I'm talking at -6, which is very loud, I want it still to be -6. But when I'm talking at 0, which should be clipping, I want it to be -6. I don't want it to clip. And I even put this, this is in the example. When I'm up at 20 plus, which is not, your system can't actually do that. I'm still at -3. I think that's just for the maths. This is the way I want the loudness to be treated. So I want quiet things to be so quiet I can't hear them anymore. But I want it to sound natural. So I don't want it to sound like suddenly the audio drops out harshly. That's why I have this -51 to -51. This is quite quiet. And this is kind of where it's, okay, now from here, get quieter. And now from here, get a little louder. It's a little step up halfway in between at 35. And then it keeps going up to 18. And now it actually doesn't raise up that much. It's so that you can hear me. Before, I would look away from the microphone and you wouldn't be able to hear what I said. So this is compressor expander, and this is attack and release, and it's 2 channels. So we have, this is channel 0, I believe, and channel 1. This is left and right. So this is in seconds. So this is 10 milliseconds attack time. So this is how fast the compressor reacts. And then this is how fast it releases. And I've noticed when I left it too fast, when I had it like 0.02, when I had a 0.02, it seemed like it was releasing too fast, and it seemed like I could hear it, and it didn't sound natural or correct. So I let the release be a little bit longer. I changed it to 5, and it sounds a little bit better. Things don't abruptly drop off when you're listening to them. But again, you can play with these and you can look up about compressors, but just understand this is a compressor and an expander. So you're basically saying what sound level is coming in and what sound level you want it to be at. But it's not exact, because this says I'm at -6, but it's not. I will still almost be clipping. So, and sometimes I am clipping. So I have a limiter on here afterwards. So this is how a compressor works. And if we see the supply, we're going to see a major change in the audio. Okay, so I'm going to save this and I'm going to run it. We're going to see quite a different, it's going to make the file much louder. So here we can see the waveforms very small. Oh, you know what I did? I didn't add it in again. I didn't add it to the list. So right here, and you can put the equalizer before or after the compressor, or even before and after it. I kind of thought about put the equalizer before the compressor and try to make it sound flat. Don't stylize it, just make it sound flat. If there's anything that's out of the blue that's weird sounding, make it just sound like a flat sound, then do the compression. And then if you want to play with the equalization of that sound afterwards, but there's different ways that you can do it. People argue about it. And again, I'm not a professional audio engineer, so I don't know the best way to do it. Okay, so we've added this compressor in. And when we open the new one up, we should see a different look. Okay, see that? It's very big here. And we see we're peaking. I'm going to turn this. Oh, wait, I can't. Can I mute this? Well, I'm going to play. It's going to be. Okay, that's enough space for the noise, and we will see what. And look, I'm at 4 here, but my volume is actually at -5. So this is clipping. So if I turn the playback up to 100%. Okay, that's enough space for the noise. See how I was targeting -6, but I'm actually clipping. So this is a problem. And I could go back through and I could reset my compressor, which is an option too. I can make my compressor. Let's see, are we in the right one? So I could lower these numbers down. They're too hot. Or if I say, you know what, I just want to get rid of those peaks, I could use a limiter. And the limiter is pretty basic. I'm just going to grab both of these. I don't actually use the volume one. So the volume one I just put in here, you can put a number here. It can be, if you just want full volume, you could just put 1. If you want 1.5 the volume, you could put 1.5 or half volume. But that's not decibels. So what did I have? 3? Yeah, 3 decibels. 3 decibels would actually be 2, I think. So 3 decibels is doubling the volume. So 2 would be doubling the volume. Something like that. But I actually don't use this, but just say your input volume or your output volume is just not where you want it to be and you want to move it around a couple decibels. You could just use this, and it's just very simple. It's just volume equals, and again, you can put it just a number, or you can put the dB for decibels. So it's self-explanatory. I'm not using it actually, but I'm just throwing it in there as another option. But this is the thing we're looking for, is the A limiter. And what we want to do is we want to level. So this does something unintended. So A limiter doesn't just limit, it actually normalizes your audio. And since I don't want my audio normalized because I'm already doing compression and everything else to get it to where I want it to be, I want to turn this feature off. So if you don't turn this off, you'll find out that suddenly your audio is way louder than you thought it was going to be. And you thought, I'm using a limiter. Why is my audio so loud? And it's because the limiter actually has a normalizer in it, and it tries to normalize it to 0 decibels. But it actually ends up making your audio louder. And you may want that, but I don't want that in what I'm doing here. So just know that A limiter, let's look for it here. This level, audio level output signal, default is enabled. So this thing is turned on by default. This normalizes audio to 0 decibels. So you might be confused. You might be saying, and I'm using a limiter. Why is my audio suddenly way louder than it was before? And it's because of this normalizer. And if I'm streaming a long audio, I don't know what it's supposed to be normalized to. And I haven't looked into that. So I didn't want to use that at all. I just wanted the limiting part of it. So you can disable it. So you can put A limiter equals level equals default. And what happens is when you have more than one option, it looks like this. This is going to look like this. When you have more than one option on a filter, if I just had one option, if I just wanted to put limit, it would be like this. A limiter equals limit equals, right? So imagine this first one is saying this thing equals whatever the rest is. When you have more than one, they're colon, not semicolon, but colon separated. And this is used in other places too, I think. So there's pipes used here. Well, no. So if we were using another pan option, the second pan option would have a colon, and it would be the second option. So the stereo is for the stereo one, but if pan had a different option we were using, it would be colon and the other option. Let's see, do any of these other ones? See right here, we have a colon, and that's for those options. So when you're doing multiple options, you're gonna have to ask like some LLMs or look up sometimes some of these commands to see how they're structured. But A limiter, again, I want the leveling turned off. I don't want that on. And then I want to limit it to -3 decibels. Okay. So this time, hopefully it won't be. So it's going to make sure anything above 3 decibels just doesn't go above 3 decibels. It's like a hard limit on the audio. And I need to make sure I put this in. So I almost forgot it again. So I'm putting this after the compressor, because my compressor may make the output audio too loud, or maybe just sometimes it's too loud. So I want to make sure that I'm not going past 0 or even 3 decibels. I'm just not too loud so that you get crackling and you get, you're popping too high on the audio. So limiter. Is what I called it. So that should be in there. So now we shouldn't be at that negative. All right. And that was the old one. And we already knew that was going up to 0. Okay. So now we already see that this is not going up to 0 anymore.
Okay, that's enough space for the noise.
So we're at -3.
See what it sounds like when I'm just talking.
Okay. But if you're really always next to -3, you should probably adjust your compressor or do something else, you know. But this one, I'm thinking it's in the range I want it to be in, but I'm just making sure none of those peaks are actually too hot. So that's how we would throw a limiter on there. Let's see what else we got. Let me click on this first. And I think that's all of it. So that's kind of how I would set up like the audio chain. And we can check this out. Let's do a so this is us doing it in a file where the file already exists, the audio file already exists, but we can do this in real time. So we don't need to do it this way. So this whole thing here that we've done here, sorry, I'm in the wrong one. This one that we've done here, we could do this in real time while we're just capturing from the mic. So this one, we're doing it from a file, but we can actually just do this from a mic. So if we look at one of the other example files over here, so I have mic capture and then I have mic capture mix. The mic capture mix is basically applying all these. So I'm not getting, I'm using the pulse, the input for the microphone. All this other stuff is the exact same. The stereo thing, the high pass, low pass, denoise, -55 and 20 for my external mic that I'm using talking into right now. These are all the same. This is the same. And this compressor, it's all the same. Volume I'm not using. Hard limiter. So I don't even need these right now. So I'm just going to delete this. And I need to put the closing quotation here. So -F pulse, because we're getting an input from the pulse audio. And this is the actual pulse audio that we did in the very beginning of the video. So we've already covered all this. I'm just going to get rid of this. We'll talk about that in a bit. So if I were to put, so I'm going to record the mic and I'm going to remove all this stuff except like stereo. So we do get a stereo signal. And then I'll put all this stuff back on and we'll see the difference. Okay. So I'm going to leave stereo. I'm just going to get rid of everything else. Okay. So that should allow me to capture my external mic that I'm talking into right now, the one that sounds better. And it'll be raw, but it'll be stereo. It won't be processed yet. So this is called mic capture mix, and it's the fish one. So mic capture, and this is the mix one. Okay. So this is a test of my external mic. I'm talking into it right now, and then we'll press Q. Okay. So we have, you know, the waveforms are not very big, but we have it in stereo. So this is a test of my external mic. I'm talking into it right now, and then we'll... Okay. So that's what it would be like. It's not too bad. Not too noisy or anything. And then we can apply all that stuff that we've been doing. So I'm going to put all that back on. So we have everything going on now. And we can just record it live now, right? Okay, this is another test of the external microphone to see what it sounds like and to see what the waveforms look like. Okay, so now it looks like this, much bigger. And it should just sound what you just heard, except it is going to be quieter because, again, I mix in my system gain at half. So it's like 3 decibels down, I think. Okay, this is another test of the external microphone to see what it sounds like and to see what the waveforms look like. We've done this, but what if we want to grab the system sound and mix it in as well? You know, we want to record our microphone, but we also want to record the system. So we can do that too. Let's see here. And I'm going to go, so all these are in different files, but they're all building up to the same deal. So I kept having this other two parts in here, and now we can kind of talk about that. So let's see, here's dual capture. Shall we look at the bash one this time? Why not? So this is the bash version, same thing. It's just the way that variables are set up is slightly different. And I think that's the only difference, is just the variable setups. So everything up here is the exact same. Nothing has changed other than it's the equal sign and there's no set because it's bash. But everything else is the exact same until we get down to right here. Right here, there's something going on here, here. We'll just put a pin in that. We'll come back to it. We have this A mix, so we can mix two audio inputs together. Yeah. So let's look at that on here. A mix mixes multiple audio inputs into a single output. That's what we want to do. And there's some, so they have this duration thing. By default, it's you can make it where one, like which one it drops out will cause the audio to stop or whatever. I actually just want the audio to happen as long as FFmpeg is running. Even if one of the audios drops out, I want the other one to keep on going. So its longest is default, I believe, the duration longest. So I just removed that option from what I was doing. And we can also set weights to it. And that's the interesting part to me, is the weights. So over here, we have the inputs. We have two inputs. So inputs equals 2. And again, we're seeing that colon here. The A mix equals, and we have the A mix equals this, basically, this whole rest. So this input equals 2, colon, weights equal, right? And what I'm doing here is I'm saying the weight of the first input is half. The weight of the second input is full. And when I'm doing this A mix thing, the first input is actually my system sound, and the second input is my mic sound. So I'm saying system sound at half and mic at full volume. Because what happens is if the system sound is at full volume, when I play the games, they're just way too loud. Like if I was just on my computer, they sound fine. But when people are listening on YouTube, it just blasts their ears. It's way too loud. And then they also can't hear me speaking. So I even had this at 0.3 before. So this would be like 3 decibels down, basically. So how does this work? Well, the audio, up here I have 2 audio inputs now. So everything else is the same. Remember, I have this A0 stereo, A0 pass. That's because it's audio. The first audio is A0. That's just how I named it. So A0 right here is my microphone that we've all been doing the whole time. A1 is the system monitor sound that we got from the Pulse Audio Control List short sources. Okay, so that's my system sound. Okay, so we have 2 of these, right? When we go down here to here, we have 2 of these. We have -F pulse, -I. So this is kind of like, here's 1, here's 2. Okay, so this first one is 0, and the second one is 1. Okay, so when we go up here, this is 0 audio. Okay, 1 audio is here. So 0 audio is the first one, 0 input, which is my microphone. 1 audio is the system audio. I'm going to put this back. Yeah. Okay, so what I'm doing here is I'm saying, hey, I have 2 audio sources. On this filter list, I'm saying I'm using the first audio source, the microphone. So this all applies to the microphone. And when it gets done with all of this, I'm giving it a name. So the name coming in, I have an audio stream coming in. I have 2 of them. I have the mic and the system, but I want to play with the mic audio. So 0A is the mic audio. So a mic audio, and I apply this to the mic audio, and what's done with that, I apply the pass, and when that's done, I apply the denoiser. And I get all the way down here, and I want to save this. I want to access it later. I'm calling this mic. You can call this whatever you want, but I just chose the name mic because this is the microphone. So this is actually the first input file, which is my mic. So that number is important. The 0 is the first one is my mic. So if I put my mic down here, it would be 1, not 0. Okay, so this is the input stream for the audio is 0. The output of how I've processed all this audio, I'm giving it a tag name. So I can later on I can get the original audio again, or I can get this what I've changed it to, this output stream of this. Okay, so I have the output stream of my mic, and then I have the system audio. I want to mix those two together. So down here, so this is the thing that mixes the two audios. But this filter down here is just another variable. I'm just organizing things. I'm saying, hey, I want to take the second audio, which is the system audio, and the microphone, which is the output of the first audio that was processed. And then I want to do this thing, which is right here. So this is just, imagine this is Amix wants two audio sources, right? And it's 1A and mic. That's why this first number, if I swap them, if I made them backwards, I would need to switch these two numbers. So it's saying I want to take this audio, and I want to mix them together. And these are the weights I want to them. So this system audio is at half volume and the microphone is at full volume. Okay. So that's all I'm doing here. I'm just separating things out because the commands get so long. So this is system audio. This is processed microphone audio. I do the mic thing on it. And then I want to do something else. I was looking for the crackling before, and that was this resample right here. Let's go look at it. So this is a resample. So a resample resamples input audio to specifies parameters using lib whatever that is. If none are simplified. So basically, where is it? This filter. It allows you to stretch and squeeze audio if they don't line up, right? So if they don't, you're gonna get kind of like buffer underrun crackling. And and it says you can resample up to the async, you can put it up to 1,000. It was fine when I just put it at 1. If I didn't have it on 1, if you listen to my live stream before, it's crackling all over the place. When I put it to 1, it was just fine. So yeah, so I'm just using async, a resample and the async to make the two audios synchronized, because when I close the games down or when I'm doing different things, they become unsynchronous, I guess, and it causes audio crackling. Again, not an audio engineer. One sounds better than the other is what I came up with. It's causing some kind of issue, whether it's lining it up or it's buffer or it's chunk sizes not matching. I'm not really quite sure, but async seems to fix it. So I'm using the audio resample equals async equals 1. Okay, so I'm just doing these two things. And this is another filter chain. So what this is this is a filter chain right here, this comma separated filter chain. And this second one is a comma separated filter chain too. This is one part and this is comma is another part. So filter complex can run semicolon separated filter chains. So this first filter chain goes through all the mic audio, processing it all along the way and gets that final result. And then it runs this other filter chain, which mixes those two audio together. So these separate filter chains and the separate different filter chains are semicolon separated, whereas inside of a filter chain, they're comma separated. So that's why I'm using this filter complex. So basically, before in the other one, I took the audio, the name of this guy right here, the audio filter, and I fed it directly into filter complex. This time, I'm just adding the two together. Right here, I'm calling it filter complex, and I'm just semicolon separating the two filter chains. So this top one is the same as before. I'm just making sure I'm using the mic audio input, and I'm giving a name to the audio output. And the second filter chain is just mixing them and making sure they're synchronized. Okay, and I'm giving a name to that. I'm giving a out to that. That's my audio out. That's my final audio sound. And that's why I'm doing that here. I'm saying, hey, my output audio, I'm mapping my output audio is going to be a out. So the audio that I'm actually going to record is going to be that final processed a out audio. And it's going to be 2 channels. It's going to use A, C, and it's saved into a file. So this time I should be able to record my microphone and a system audio. Yeah. Let's see if that is what happens. So we need some kind of system audio. So what I'm going to do is I'm going to hit record on this and I'm going to run and do something else that's going to make sound. Okay. So this is dual capture. And it's the bash version, right? Okay, it looks like it's working. So let's switch to, this looks good. So this is, I don't know about these colors. It looks a little bit Redmond to me. I think Cappuccine is better. There we go. There we go. Cappuccine, let's get, this display needs to be a little bit bigger. So ×2 is nice, but the resolution's too low for games. Okay, so what if we want to play a little snowman? C, STL2. Okay, and we can say make, run, that should work. And we should have audio. And it should be being recorded. Okay. And it does crash at the end. That's not my program's fault. It's Serenity OS. They're still, in early days. So let's switch back to here and close this. Okay. Okay, it looks like it's working. So let's switch to, let's go over here. C, STL2. Okay, and we can say make, run, that should work. And we should have audio. Yeah, that worked. That recorded. And it should be. Okay, so that gives you audio and system mixed together, and you can change the volumes if you want. Okay, so yeah. So now I hope if anybody's following along, they kind of understand all these weird steps I'm taking to build this up, because this is just the audio. What happens when we start getting into messing around with the video, I'll just show you, and you'll completely understand why there's so much variables going on here. If we were, say, recording in a video, it starts to look a little bit longer. This is my FFmpeg to record audio and video and stream it to YouTube and stream it to Twitch and save a local copy. And if I were to have all these variables populated, this command would just be a book. It's going to be very long. So, and you see the same thing going on here. I'm getting audio inputs. I'm doing all this same stuff. Looks the same here. Equalizer, compressor, and mixing the 2 audios together. And then I have some video filtering and some other video stuff going on here, and acceleration and stuff like that. So that's kind of a bunch of stuff about audio using FFmpeg. Again, you can use it to stream, but that would kind of be in the video. I'll make another video about this, talking about video, not audio. This is all about audio. This is how you can use FFmpeg. You can record live, or process already recorded. You can do pretty much everything that you can do, but it's all in command line. So I kind of made different scripts to show how to do it. And for anybody who was who is playing around with this operating system here, this Serenity OS, my stuff actually compiles just fine on here. The only thing I needed to do, let me just show. I'll switch to the easier to read resolution. This is just a side track here. Let's see. If we go into a text editor here, and let's open. It's probably an initialize. Initialize C is the place, specifically in this one, I had to change something. So it's in the render. So I hard-coded acceleration into the render right here. So the only thing I needed to change in this entire process was right here. It was using the SDL render accelerated. I just changed it to 0. So I think it tries accelerated and falls back to software because I think there's no render acceleration happening right now or something. I'm not really sure the state of SDL and Serenity OS. This is a different operating system if you ever heard of it. It's not Linux, it's not BSD, it's its own thing. It's the people who created. Oh, and I can even use Vim bindings or whatever. Where is it? Vim emulation. But yeah. The only thing I needed to change was putting a 0 there. And then, yeah, you can compilation, just no problem. But you saw when it closes, it... and I didn't change anything else. So this is just my normal make command running. And that's running the debug version too. Let's see here. Cannot find. Oh, okay. So the debug version won't work because I'm probably missing something else or something else can't work. But the make, clean, make, release, this one does work. The debugging one, just the make by itself for debugging, is like doing a lot of checks and using other things. But it looks like I don't have this installed. I'm not sure if that's something I can install. I probably can. I just don't have it installed. And then make run. And, you know, but the resolution's twice the size here. Okay. That's just for, and it crashes on exit, but that's not my code that's crashing. That's something with Serenity, but it's fine. Okay, anyway, like you can find all these scripts that I've been talking about on here. I threw them in there. Just know that you'll need to change it to your needs, what you want your EQ to be. You're going to need to figure out your own EQ, your compressor. It takes some time trying different things, seeing what works best for you, what you want your limiter at and stuff. But so these are the scripts that I have, but they're with the values that I'm using. So your values won't be the same. Also, your mic, you won't be using the same audio interface that I'm using. So the name, you'll have to change those things out. Where is it? Right up here. You'll have to change these names, but here's the command that you get those names from for your system. And just the way I showed how to find the noise floor, you're probably going to have to do something like that for the noise floor. The way I was showing how to equalize, or your own method to get your values for equalizing. Again, this is kind of my idea how to do this compression. You might have your own ideas. But this is just showing you how to throw them all together and get them all to work and stuff. That's going to be it for this one. I hope you enjoyed that, or I hope it was entertaining, or I don't know. I hope you enjoyed seeing Serenity OS maybe. So have a good day and see you next time. Bye.